Now we investigate how the graph of y equals a times f of x is related to the graph of y equals f of x. Okay, so for the different real numbers a. So comparing y equals a times f of x to y equals f of x, we see that the graph of y equals a times f of x can be obtained. Similarly shifting idea from the graph of y equals f of x by how? Actually, I will explain by multiplying each ordinate y value, each ordinate of the ladder by a. So the result is a vertical stretch of the graph of y equals f of x if a is bigger than 1. Okay, so the result, why? Because ordinate will increase. The result is a vertical stretch of the graph of y equals f of x if a bigger than 1. Let's sketch the graph and observe the graph from the absolute value function again. X, y axis. So absolute value of the x graph is this one. Y equals absolute value of the x. So for example, let's multiply 2. So ordinate value will be increased 2 times. Okay. So for example, for this value x, this is x value. But now we have 2x, okay? So 2x somewhere here. So the graph will be like this one. For the point 0, there is no problem. This is the same. So this is y equals 2 times absolute value of the x. So we vertically stretch if a is bigger than 1. A vertical shrink, okay, let's say a vertical shrink of the graph of y equals f of x if a between 0 and 1. So in this case, for example, you multiply 1 over 2. You can observe this is x over 2 values. It's passed through at this point. So we have this graph. So y equals 1 over 2 absolute value of the x. Okay. So this is vertically shrink case. And a reflection in the x-axis if a is minus 1. So all cases find in this way. For example, if a is minus 2, you should consider as a combination of the first case, a is bigger than 1, which is 2, and we multiply also minus 1, okay? If a is minus 1 over 2, again, by combining the second case, vertically shearing case, and the reflection case, you can obtain the graph. If a is equals minus 1. If a is negative number other than minus 1, let's explain. If a is a negative number, other than -1, then the result is combination of the reflection. Then let's continue here because I needed some space. Then the result is a combination of a reflection in the x-axis and either a vertical stretch or vertical shearing. A vertical stretch or a vertical shearing. Okay, so let's consider this reflection. For example, -1x. So if you multiply -1x, you obtain this graph. So this is the y equals minus absolute value of the x. So let's look the following example. Let's consider this one. This is graph of the absolute value of the x function. For example, our aim is to sketch the graph of the y equals minus 3 absolute value of the x. So 3 absolute value of the x graph like this one. This is y equals 3 absolute value of the x. Then by reflecting in the x-axis, we find this graph. This is y equals minus 3 absolute value of the x. Or let's consider another graph. 1 equals minus 1 over 2x. 1 over 2x graph like that one. Okay. This is y equals 1 over 2 absolute value of x. By reflecting x-axis, we find this graph. So this is the y equals minus 1 over 2 absolute value of the x graph. So by that way, you can sketch easily graph of the this type of the function. Also, it is possible to sketch the graph of the any combination of the translation and the stretching shearing idea. Okay, in the problem solving hour, I will solve such type of the questions.